We're going to look at page 282, question number 1. So, water at a pressure of 3 times 10 to the 5 pascals flows through a horizontal pipe at a speed of 1 meters per second. The pipe narrows to 1/4 its original diameter. What is the speed of the flow in the narrow section? So if we want to draw a picture of what's happening, we've got flowing through a pipe. The pipe narrows to about the diameter D2. This diameter is about 1/4 the original diameter. Now the speed of the fluid is 1 meters per second over here. We want to know what's the speed of the fluid here. One more piece of information it gives you is the pressure over here. Is 3.00 times 10 to the 5 pascals. Okay. So I see here I want to know the speed. An equation I know to relate speed and the cross-sectional area is A1 V1 A2 V2, where A is the cross-sectional area. That's this area. That's A1, and A2 is this area. Okay. Well, this is a circle. So what's the area of a circle? Well, A1 is equal to pi R1 squared, where R1 is the radius. Now, let's try to put it in terms of diameter, because that's what we have. So I can say this is pi. To get from radius to diameter, I know that if I just divide my diameter by 2, I get back my radius. I could do the same with A2. Pi R2 squared. R2, I could say it's D2 all over 2. But here, now I can relate A1 and A2. Look, we have a D2 here. And I know that my diameter, my new diameter, is 1/4 of my old diameter. So let me sub that in here. Okay. All I did was I subbed in this into here. That leaves me with pi D1 all over 8 squared. All right. So let me sub in these two back into our equation, our original equation. So we have pi D1 all over 2 squared times V1. In our question it says 1 meters per second. A2 pi D1 over 8 times V2. This is what we're trying to find, V2. Okay, let's see what I can cancel here. Cancel the pi's on both sides. What I would do is divide both sides by pi. Pi divided by pi is 1. 1 times any number just gives me back the number. Okay. Now, let me expand these two terms to show you what happens. D1 squared all over, we got to square the 2 as well. 4. Square the top, D1 squared, square the bottom. 8 times 8. Okay, now again, I could divide both sides by D1 squared. And that gets rid of my D1s. D1 divided by D1 is 1. Any number times 1 just gives me back the number. So maybe this is starting to make sense why we went through this entire process of putting D2 in terms of D1. So when I get over here, now I can cancel out my D1s. It's no longer part of the equation. So I have 1 meters per second divided by 4 is equal to V2 all over 64. So now it just comes down to solving for V2. So V2 is equal to, multiply both sides by 64. 64 divided by 64 gives me my 1. So I got 64 divided by 4 times 1 meters per second. What does this give me? 16? 16 meters per second. So that's my speed of the fluid at some point over here. Now, one last thing to point out, we didn't actually end up using it, but the pressure over here was 3 times 10 to the 5 pascals. Now, if our speed goes up, what happens to the pressure? Bernoulli's law tells me as the speed increases, the pressure decreases. So we'd expect this number went from 1 to 16. So if this number increases, we'd expect our pressure to decrease.